Types of chemical reactions. Prelab discussion. There are many kinds of chemical reactions and several ways to classify them. One useful method classifies reactions into 4 types. These are: number 1, direct combination or synthesis; number 2, decomposition or analysis; number 3, single replacement; and number 4, exchange of ions or double replacement. Not all reactions can be put into these categories. Many, however, can. In a synthesis reaction, 2 or more substances, elements, or compounds combine to form a more complex substance. Equations for synthesis reactions have the general form A plus B yields AB. For example, the formation of water from hydrogen and oxygen is written as 2H2 plus O2 yields 2H2O. A decomposition reaction is the opposite of a synthesis reaction. In decomposition, a compound breaks down into 2 or more simpler substances, elements, or compounds. Equations for decomposition reactions have the form AB yields A plus B. The breakdown of water into its elements is an example of such a reaction, where 2H2O will decompose to form 2H2 plus O2. In a single replacement reaction, one substance in a compound is replaced by another, more active substance, an element. Equations for single replacement reactions have 2 general forms. In reactions in which one metal replaces another metal, the general equation is X plus YB yields XB plus Y. In those in which one nonmetal replaces another nonmetal, the general form is X plus AY yields AX plus Y. The following equations illustrate these types of reactions. Where zinc replaces copper 2 ion, where zinc solid plus aqueous copper 2 sulfate CuSO4 will produce zinc sulfate ZnSO4 aqueous plus solid copper. Or, for the nonmetal, chlorine replaces bromine ions, where Cl2 gas reacts with 2 moles of KBr, potassium bromide, to produce 2 moles of aqueous KCl, potassium chloride, plus liquid bromine, Br2. In a double replacement reaction, the metal ions of 2 different ionic compounds can be thought of as replacing one another. Equations for this type of reaction have the general form AB plus CD yields AD plus CB. Most replacement reactions, single and double, take place in aqueous solution containing free ions. In a double replacement reaction, one of the products is a precipitate, an insoluble gas, or water. An example is the reaction between silver nitrate and sodium chloride, in which the precipitate, silver chloride, is formed, where AgNO3 aqueous, silver nitrate, reacts with sodium chloride, NaCl aqueous, to produce solid silver chloride, AgCl, and aqueous sodium nitrate, NaNO3. All of these types of reactions discussed here may be represented by balanced molecular equations. Reactions involving ion exchanges may be represented by ionic equations also. In this investigation, you will be concerned only with molecular formulas and equations. In a balanced equation, the number of atoms of any given element must be the same on both sides of the equation. Multiplying the coefficient and the subscript of an element must yield the same results on both sides of the balanced equation. In this investigation, you will observe examples of the 4 types of reactions described above. You will be expected to balance the equations representing the observed reactions. So, the equipment that we'll be using: a Bunsen burner, crucible tongs, a microspatula, test tubes, a test tube holder, and a test tube rack. In addition, we will require wood splints, sandpaper, an evaporating dish, safety goggles, and a lab apron or coat. The materials include mossy zinc, copper wire, magnesium ribbon, copper 2 carbonate, and 6 molar hydrochloric acid, or HCl. 1 molar copper 2 sulfate, 0.1 molar zinc acetate, 0.1 molar sodium phosphate, and 1 molar sodium sulfite. Okay, the procedure. Use fine sandpaper to clean a piece of copper wire until it's shiny. Note the appearance of the wire. We're going to use a piece of copper metal here that is actually a reddish color, reddish brown color. And using crucible tongs, place the wire in the hottest part of the burner flame for 1 to 2 minutes. Examine the wire and note any change in appearance caused by heating. So we're going to place the copper metal in the fire, the hottest part of the flame, and you see copper actually burns greenish. That's actually part of something called a flame test, where copper will burn green. And we see that the copper is no longer a reddish color, it is now a blackish gray color. That's because the copper has reacted with oxygen in the atmosphere to produce copper 2 oxide. Next, place a dish near the base of the burner and examine a piece of magnesium ribbon. Magnesium is a silver color. It's a silver color. And then, using crucible tongs, hold the sample in the burner until the magnesium starts to burn. Then it says, do not look directly at the flame. Hold the burning magnesium away from you directly over the evaporating dish. When the magnesium stops burning, put the remains in the evaporating dish and examine the product. Okay, so basically, magnesium has reacted with oxygen to form a compound called magnesium oxide. Magnesium was silver color, magnesium oxide is white. Both of these reactions with the copper and the magnesium represent a synthesis reaction where oxygen was a product, was a reactant. Then it says, place two heaping spatulas of copper 2 carbonate in a clean, dry test tube. And then it says, note the appearance of the sample. Well, the sample is green. Say green color. Then using a test tube holder, heat the copper 2 carbonate strongly for about 3 minutes. Then it says, extinguish the flame and insert a burning wood splint into the test tube. If carbon dioxide gas is present, it will put the flame out. Note any change in appearance of the residue in the test tube. Well, we can see that the sample is actually turning black. And we can also see that the sample is actually moving up in the test tube. So now I'm going to light my wood splint and place it in the test tube, and the flame immediately goes out. That's because carbon dioxide gas is being formed, and some fire extinguishers actually use carbon dioxide gas to put out a fire. Fire will not burn in carbon dioxide gas. This is called a decomposition reaction because copper 2 carbonate formed copper 2 oxide, which is the black color here, and carbon dioxide gas, which actually put the flame out. Number 6, stand a clean, dry test tube in the test tube rack. Add about 5 mLs of 6 molar hydrochloric acid. Just going to add a few drops here. Drop a small piece of zinc in the acid in the test tube. Observe and record what happens. Well, I put some zinc in it. You can see the zinc is actually bubbling. Now, it's bubbling because it's reacting with the hydrochloric acid. This is called a single replacement reaction. The bubbles that you see here are actually hydrogen gas formed when the zinc reacts with the hydrochloric acid. So the result of this reaction is zinc chloride and H2, hydrogen gas. It's also an exothermic reaction because the test tube is actually getting warm. Then it says, using a test tube holder, invert a second test tube over the mouth of the test tube in which the reaction is taking place. So I'm going to invert a second test tube over that. Then it says, see figure 14-1, remove the inverted test tube after about 30 seconds and quickly insert a burning wood splint into the mouth of the test tube. A pop indicates the presence of hydrogen gas. So we kind of knew hydrogen gas was being formed anyway, but let's see. Whoa. So we definitely got a pop. This is actually called a pop test that actually confirms the presence of hydrogen gas. Number 8. Add about 5 mLs of 1 molar copper 2 sulfate. That's this blue stuff right here. Solution to a clean, dry test tube. So I'm going to add about 5 mLs. That looks like about 5 mLs to me. Place a small amount of zinc metal in the solution. Note the appearance of the solution and the zinc before and after the reaction. So zinc is a substance that's actually a silver color, and I'm going to now put, and this is a blue color. I'm going to place some zinc into the test tube, and immediately the zinc starts to turn a dark, almost black. And it's actually starting to create a gas a little bit. So I'm going to leave my zinc. There it is. So the zinc is starting to turn red, which means that the copper is come out of the solution where the copper 2 sulfate was added to zinc, and now the copper is being exchanged for zinc. This is called a single replacement reaction, where copper is being replaced by zinc, forming copper metal. You can see the copper metal forming in the test tube. We'll come back to this later to see how far the reaction actually proceeds. But you can see the copper is actually replacing, the zinc is actually replacing the copper in solution. Number 9, place about 2 mLs of zinc acetate. I'm going to place about 2 mLs of zinc acetate. Okay. Into a clean, dry test tube. Add about 2 mLs of sodium phosphate. This is sodium phosphate. Sodium phosphate. And observe what happens. Note any changes to the mixture. So when I added the zinc acetate to the sodium phosphate, look, it made a white precipitate. When a solid is formed from a reaction, it's called a precipitate. So this reaction is called a precipitation reaction, which is also known as a double replacement reaction. So double replacement reactions and precipitation reactions are synonymous. Number 10 states, add about 5 mLs of sodium sulfite. Add about 5 mLs of sodium sulfite. That's about 5 mLs. Solution to a clean, dry test tube. To this solution, add about 5 mLs of 6 molar HCl. This is also a double replacement reaction, by the way. although a precipitate does not form here. Then it says, note the odor given off by wafting some of the gas towards your nose. And I smell the odor of burnt sulfur coming from the test tube. So this is probably the odor of sulfur dioxide. Now we have to go to the observations and data. Oh, by the way, this was also a double replacement reaction. So now we must go to the observations and data and fill out the observations and data page, and then we have some equations to do, and then we're done with the lab.